In this video today, we're going to talk about the discriminant. How do we use discriminant properly? And what is the difference between the d and the d over 4? So what I mean by d is the discriminant that looks like this. And this is the regular form. However, we have an alternative form, which is d over 4. And what was the difference between them? To start with these two information, we have to start with 122. The reason why we want to start with 122 is that I want you guys to read it. In a quadratic equation ax squared plus bx plus c equal to 0, the discriminant d equal to b squared minus 4ac allow us to determine the different types of solutions. In this case, let's draw a little graph here. We have a quadratic function and a curve that looks like that. And notice that this curve have two intersections with the x-axis. In this case, d should be greater than 0, which corresponding to this thing over here. And let's draw another graph. Similar graph, it's also a quadratic function, it's also a curve, all right, parabola. However, in this case, we only have one intersection right here. So what does that mean? That means that d is equal to 0. And last but not least, let's draw another graph. In this case, you see that there's no intersection with the x-axis. So that's why d is smaller than 0. In these three circumstances, we will have completely different solutions for the quadratic function. And also, we kind of showcase it in a graph. So in order for us to determine how many, actually, it's a very easy way for us to determine how many roots or how many solutions do I have for a quadratic function. So we just use a coefficient, the a and b and c. What I mean by that is that the standard form for our quadratic function is ax squared plus bx plus c. Most of the time, we'll need to solve the quadratic function using the quadratic formula or even using factorization to see, okay, how many roots do I have, or do I have some roots at all? Using the determinants, we have the capability of looking at the different coefficient, which is the a, the b, and the c, to determine, okay, how many solutions do I have? The differences, however, between d and d over 4 is the fact that d over 4 is a simpler version of the determinants d equal to b squared minus 4ac. And their differences are like this. So let me explain this briefly over here. How do we get d over 4 and equal to b prime to the power of 2 minus ac? They're actually kind of similar. Okay, so giving you the sense right now, let's do ax squared plus bx plus c. In this case, we assume that b can be divided by 2, like a wholly divided by 2. So b can be b over 2 times 2. So the original function becomes ax squared plus 2 times b over 2 times x plus c. In this case, right here, we can call this b over 2 b prime. And then we will have a function that looks like this. ax squared plus 2b prime x plus c. The reason why we want to substitute b over 2 into b prime is just for the ease of our operation right here. Okay? So now, if we use the determinants, which is d equal to b squared minus 4ac, it's not hard for us to say that, okay, you know what? B squared should be 2b prime to the power of 2, right? And then minus 4ac. Okay, so in this case, it will be 4b prime squared minus 4ac. And we know that the 4 and the 4, I can factorize it out. 4 times b prime squared minus ac. And what was the difference between this one? Oh, I forgot one of the bracket here at the beginning. And also is this one. They're the same. The only thing over here is that, hey, the one that I just solved over here, it has 4 times more. But in a sense that 4 is always going to be a positive number. So it doesn't matter what's inside the bracket. It can be a negative, it can be 0, it can be positive, but the 4 would not influence the positivity or negativity was whatever is inside. So that's why in this case, if the b that we see, the coefficient, is a number that can be divided by 2 easily, we normally use b prime instead of just the b. It's just the ease of us doing it. Let's try one of the question here. Okay. Let's try question number 2 here. And we're trying to determine the value of k for which the given function equation has a repeated solution. Okay, so what does repeated solution mean? It means that d is going to be equal to 0 or d over 4 is going to be 0. We're going to do both. For d equal to 0, which means that we're going to use this is b, this is a, and this is c. So b squared is basically minus 8 to the power of 2 minus 4 times 3 times k. And then 64 minus 12k is equal to 0. So we're going to figure out the number that is equal to, make the whole thing 0. So k is equal to 64 over 12. In another word, it's going to be 16 over 3. So k can be 16 over 3, right? And let's use the other one. If I use d over 4, what I would use is that, my bad. What I would use that, what's the b prime? In this case, b prime is minus 4. Because minus 4 times 2 is minus 8, so that's why it's b prime times 2 is equal to b, right? Okay, so given that, and remember that, we know that b prime minus ac. And see how easy it is. B prime squared, okay? Minus 4 to the power of 2 minus 3k. And we know that that's 16 minus 3k. K is equal to n equal to 0, equal to 0. K is equal to 16 over 3. That's exactly the answer over here, right? Okay, let's try question number 4 here. For question number 4, it's not hard to see that, okay? That's A. And that's our B. And that's our C. Okay? Also, K will be our B prime because 2K is 2 times B prime. Okay? We're going to use D first. D is equal to B squared, which is 2K squared, minus 4 times 3 times 2K minus 3. And D over 4, we're going to write the same thing, is equal to K squared minus 3 times 2k minus 3. In this case, we're going to do the second one first. It looks easier, right? K squared minus 6k plus 9. Hey, what does that look like? Oh, that looks like a perfect square. If that is equal to 0, so then k minus 3 to the power of 2 is equal to 0. So k should be equal to 3, right? And then the function of this will have a repetitive solution. Together with this one, let's see our calculation is sharp enough, okay? 4k squared minus 24k, right? Plus 36, okay? Is equal to 0. You notice one thing. You can actually factorize the 4 out. K squared minus 6k minus 9. It's literally the same thing. Once you do that, because again, the 4 over here would not determine whether it's a positive or negative because it's always going to be a positive number. So that's why k is equal to 3. So I get, again, the 3, the same number over here, k is equal to 3. That will make these quadratic functions having repetitive solution. Okay? So 125 over here is that in each of the following exercises, determine the value of a for which the given equation has a real number solution. What does real number solution mean? We talk about in the graph that real number solution whether means that it has one repetitive, it has 2 repetitive solution, which is 1 solution, or 2 solutions. So in this case, the d or d over 4 would be, right, d or d over 4 would be greater or equal to 0, because when it's equal to 0, it only have one solution. When it have greater than 0, it has two solutions. So both scenario, it has real number solutions. Very easy to understand. We're going to do one questions. We're going to do question number 4. In this case, hey, A, this is B, this is C. Okay, so which means that D, in this case, I'm not going to use D over 4 because I really don't want to be dealing with a fraction. And then in that case, D over, if I'm using D, right, it's B squared minus 4AC, easy peasy. If I'm using D over 4, it will be B prime. What is B prime in this case? B prime is negative 3 over 2. Oh, I hated it. I don't want to use negative 3 over 2. I just want to be using the whole number here. So it will be equal to 9, which is minus 3 to the power of 2, right? Minus 4 times 3 times 1 minus a. In this case, 9 minus 12 plus 12a is equal to, oh, actually, it's greater or equal to 0. Greater or equal to 0 and greater or equal to 0. And negative 3 plus 12a greater or equal to 0. 12a greater or equal to 3. And a is greater or equal to 1 over 4. So as long as a is greater or equal to 1 over 4, the equation will have real number solutions. Okay, so the rest, it's pretty much the same thing. I want you to try it out yourself, and that concludes today's video.